And let's take a look at discrete random variables. Now remember, a random variable, a numerical measure of the outcome of a probability experiment, so its value is determined by chance. Random variables are denoted using letters such as x. Now if you get a discrete random variable, a finite number of values or a countable number of values, the counting process, key, there's no decimals here. That's the main thing on this part. Now continuous has infinitely many values, and these values can be associated with measurements on a continuous scale in such a way that there are no gaps or interruptions. But the key thing here is it has decimals. That's going to be our whole driver on these. I should say has decimals or could have decimals. You know, you may have the 5, but it's a possibility to have 5.1. Now, probability distribution. We've looked at this already. This is for a discrete random variable x. Provides the possible values of the random variable and their corresponding probabilities. Can be a table, graph, or math formula. We've looked at creating a table, but we'll look at ones already existing in this chapter. You could have a graph or, again, the actual formula. Just to refresh your memory on probability distributions. And this is referring to the histogram, but has probabilities on a vertical scale that must satisfy. Remember, all of your probabilities add up to 1. And then all of your probabilities must be between 0 and 1. Let's look at our first problem here. It says, determine whether the distribution is a discrete probability distribution. If not, state why. Well, the answer here is no, it's not a probability distribution. We can't have negative exponents. So no negative, just say negative exponents. No negative probabilities. That didn't sound right when it came out. Even more than that, these don't add up to 1. That's 1.2 minus 0.4. That doesn't add up to 1. So there's two reasons here. Doesn't add up to 1. Excuse me. Now the mean of a probability distribution is the sum of each x value of the random variable, times the corresponding probability. Well, let's take a look at one of these. I got x. Oops. What did I just do there? X. And then p of x. So x is 0 through 3. And p of x is 0.20, 0.30, 0.10, and 0.40. Now our formula here, we got x times p of x. So I want to create a new column where I multiply x times p of x. 0 times 0.20 gives us 0. 1 times 0.30 gives us 0.30. 2 times 0.10 gives us 0.20. And 3 times 0.40 gives us 1.20. Now this sum is the sigma here. That means sum it up. So our sum of x times p of x would give us 1.7. And this is our mean. And that's represented with this notation. So that's our mean. Now, let me show this on the calculator. If I was doing this on the TI3, TI4, I'd want to put my x values in L1, put my y values or p of x values in L2. So I'm going to go to Stat, do enter on edit, and clear those out. I'll clear all of them out because I got some extra junk left over from the previous problem. Okay, so put our x values now 1. So we got 0 through 3. 0 enter, 1 enter, 2 enter, 3 enter. Right arrow over, and I got 0.2, 0.3, 0.1, and 0.4. Probabilities in L2, X values in L1. And we'll exit out, so do second mode. And we'll press our stat, right arrow to calc, we'll choose one of our stats. And I do second 1, comma, second 2. Enter. And you see the X bar there? Well, that's our 1.7. So that's how you do it on the calculator. Now, interpretation of the mean of the discrete random variable. Given n trials, as n increases, the value of the mean of these independent trials approaches mu sub x. As n increases, difference between x bar and mu sub x goes to 0. So this is just saying that if we take enough trials, that the theory and the real life will be one and the same. That's all that's saying in a sense. Now, expected value. You hear this. They say, what's expected profit? What's expected sales? What's expected value? Whenever they're talking about that, they're talking about the mean, where you're taking your x values times their corresponding probabilities, and then you're adding them together. Now, x could be whatever you're referring to. So let's take a look at an expected value problem. It says small widgets can result in a profit of 10,000. Mid-size can result in profit of 20,000. Large-size widgets will result in a profit of 80,000. There's a 15% probability for small widgets, 25% probability for mid-size widgets, and 60% probability for large-size widgets. And what we want is up in the title here. It says find the expected profit. Okay, so we got small, mid, and large. And here's our profit, which is going to be like our x values. And over here is the percent, which is our p of x, our probability. So small was 10,000. Mid size is 20,000. And large is 80,000. Now, probability of small is 15%. Of mid is 25. And large is 60%. Okay, so our expected, what are we talking about? Profit? Yeah, expected profit here is going to equal to mu sub x so mu sub x, which is equal to 10,000 times 0.15 plus 20,000 times 0.25 plus 80,000 times 0.60. Let's see, 10,000 times 0.15. Times 0.15 plus 20,000 times 0.25 plus 80,000 times 0.60. So our expected profit will be 54,500. Again, we don't know what we're going to have. You know, we know the profit for small widgets is 10,000, for mid-size is 20,000, for large it's 80,000. And there's a 15% probability, like for our sales, will be on small widgets. 25% probability will be on mid-size, and 60% will be on large. So those will give us our expected profit. Well, standard deviation of a discrete random variable is given by these formulas. Sigma sub x is equal to square root of the sum of x minus mu sub x, squared times p of x, or the bottom formula. Now the benefit of this is we only have to put the mean in there once, so we don't have to put it in there for every line item. So the second one's a little bit easier, actually. We'll come back to that formula. And variance then is take square of the standard deviation. Let's go back to our original problem, and we want to continue it. Now for number 4 here, remember from problem number 2, our mu sub x is equal to 1.7. So we got our x and our p of x. X is 0, 1, 2, and 3. And this is 0.2. Trailing zeros at the end you can go ahead and drop off. 0.3, 0.1, and 0.4. Well, this implies that we need an x squared column. So I'm going to create that. So we got 0 squared, which is 0. We got 1 squared, which is 1. 2 squared, which is 4. And 3 squared, which is 9. Now we're doing the bottom formula here. We got x squared times p of x. So we're going to have a new column. We'll take x squared times p of x. Well, x squared we said was 0 times p of x, which is 0.2. That gives us 0. X squared, which is 1, times 0.3, which gives us 0.3. And 4 times 0.1, which gives us 0.4. And 9 times 0.4, which gives us 3.6. I'm not very good with decimals, so hopefully those are right. Okay. Then we got the sigma in front of it. That implies we want to add them together. So we're going to have the sum of x squared times p of x. That's 4.3. Okay, so now we're ready to plug in our formula. So mu sub x is equal to square root of the sum of x squared times p of x times minus mu sub x squared. Well, we just said the sum was 4.3 minus mu sub x, which was 1.7 squared. So we'll do second x squared for the square root, and we got 4.3 minus 1.7 squared. And we get 1.19, taken in 2 decimal places. Okay, let's look at this on the TA3, TA4. Well, to begin with, we need under stat edit, we need to have our x values in L1. So we got 0 through 3, that's fine. And under L2, we need our p of x, which is 0.2, 0.3, 0.1, 0.4, which is correct. So I exit out. I'll do a stat, right arrow to calc, and I will choose one of our stats. And I'll do second 1, comma, second 2. And then press enter. Now the sigma x down here is our standard deviation, which is 1.19, which is what we came up with by hand. So, and then our mean again is the 1.7 up here. So one of our stats actually gives you both of them. Just to recap what we've been going over here, for TA3, TA4 instructions, I put x values in L1, probabilities in L2, and then you do one var stats L1, comma L2. And let's go ahead and stop the recorders.